My name is Amisha Patel. This is my ID card, and I am going to demonstrate assessment 2 for IFN 584. So, I will briefly explain my system design. So first CRC cards. So first is the game class, which is responsible for controlling the whole game, like managing the turns, checking win conditions, and controlling everything. After that, there is a board class, which is responsible for places disk and applies the gravity. Then the player class. It represents each player, which uses the strategy and decide the moves. Now let's move forward to the class diagram. So this is my class diagram, which shows the overall structure of the system. The game class is the main class, which connects everything together. It interacts with the board class, then the player class, move strategy, and other classes too. The player uses the move strategy, which allows the both human and computer player. Here, the abstraction is used through the game mode and the move strategy. So, different rules and um, strategies can be added easily. The inheritance is also used here in the disk class, where the ordinary disk, the boring, exploding, and magnetic disk are the extended by the base class, which is the disk class. I also use the history manager and the game state, which support the undo and redo functionality. Uh, Now the object diagram. So this is my first object diagram, which shows the normal gameplay. There are objects like game 1, board 1, player 1, and player 2. The board shows the current state of the game, which have a uh, disk placed in each player in their own disk. So the mode 1 object represent the current game mode. In this case, this is the classic mode. The last move object, it represent the most recent move, which is made by player 1. Now object diagram 2. So this shows the system after exploding the disk, which have placed in the board. The exploding disk 1 object, this represent the disk that triggered, and when the explosion uh, disk is placing in the board class. So when the explosion triggered, uh, it removes the all the surrounding disk around the exploding disk. So and after that it update the board, which shows the empty space over here where the disks were removed. And the last move object, it indicates the player 1 that used the explosion disk. This shows the polymorphism, so where different disk type have a different behaviors. Now let's move forward to the sequence diagram. So this is my sequence diagram. It shows how player interact with the game. Um, so here the player 1 makes a move. Then the game ask move strategy to decide the move. The strategy returns a move object with a selected column and disk. The game then tells the board to place a disk. Then the board updates the grid and applies the disk effect. The game mode applies rules and check for win conditions. Then it switches to the turn to the next player, and then it saves the whole current state and of the player one. Now sequence diagram too. This is my second sequence diagram which perform the undo operation. So when the user perform undo operation, it sends to the game class. This send request to the history manager. The history manager pop the stack, it undo the stack and return the current previous game state to the game. Then the history manager retrieves the previous game state. This game state contains the board, player, player one moves and two moves. Then it gives the information of the last move. Then it restored the state effectively. Then it reversed the system. This demonstrates the memento pattern where the previous state are stored and restored. So here I use the all OP concept. So first the encapsulation. So encapsulation is used for hiding the internal data like board class. Abstraction is used for game mode and move strategy. And inheritance is used in a disk and also the subclass which are the exploding disk, magnetic disk and boring disk, kind of a special disk. And the last polymorphism, it shows when different disks behave differently using the same method. So this is my overall design. Thank you.